Hello and welcome to our number and algebra debate. Thank you for joining us this evening. My name is Victoria, I'll be your host, and we will be exploring some beautiful mathematical concepts. Let's get started. So what's the context for today's debate? Today we'll be focusing on the Year 1 mathematics strand, focusing mainly on the number and algebra substrand. The content descriptor for today is ACMNA012. Develop confidence with number strategies to and from 100 by 1s from any starting point. Skip counting by 2s, 5s and 10s starting from 0. We've also got a little sneak peek at our definition for diversity there. Teaching for equity is much more than providing students with an equal opportunity to learn mathematics. There's more of that available in your handout that you've been given before the debate began today. Let's get started. So what learning needs might arise in the context of a Year 1 mathematics classroom? Students have had the opportunity to gain so much knowledge from the outside world, and different opportunities and information can come from these. Some students are gifted, some of them struggle with dyscalculia or disengagement, some of them come from different backgrounds following our ESLDs, some of them just have a maths anxiety. They're just anxious about their ability to do mathematics that hinders the calculation. Some of them struggle to form mental representations of mathematical concepts, and then there's difficulty keeping numbers in working memory. Focusing mainly on not understanding counting principles, students might struggle to comprehend one-to-one correspondence, order relevance, cardinality, or the last counted word stated, indicates the amount, and writing need recognition, so developing that basic number sense. Students should have a basic understanding of all of these if we're entering our Year 1 classroom context. Keeping these learning needs in mind, let's meet the resources that will be compared today.
When skip counting by 2s, this pattern or trend goes 2, 4, 6, 8, 10, and so on. The only thing that is changing is the number in the tens place. 12, 14, 16, 18, and 20. So this trend begins to appear. 2, 12, 22, same with 3, 13, 23, and so on.
So say we ask students to skip count by 2s. We would ask that they group the bears by 2 at a time, like so. 2 bears. And then we would ask that they communicate their thinking. So they could do this either written, like I'm doing here, 2 for the group of 2 bears, or they could communicate this verbally. Either way, it's an important thing to encourage this communication, to know that they're on the right track, and also to encourage them to think about how they're working through the problem as well. So then we'd ask for another group of 2. And again, let's write down their thinking. 1, 2, 1, 2, 3, 4. So we'd put 4 down here. Then we'd ask for another group of 2. How many now? 1, 2, 3, 4, 5, 6. 2, 4, 6. So they can really begin to see that pattern forming here. And that will really help cement their understanding of skip counting by 2s, 5s, and 10s.
The linear character of the number line, represented as open number lines, allows students to visualize and self-partition their own number line relevant to their needs when answering a question. Students are therefore in charge of their own learning and can use their initiative to utilize this tool when answering other questions by themselves. Students are able to apply intuitive reasoning and creative solution strategies when given freedom to develop these strategies independently. They can refine more sophisticated strategies to support their learning needs or understanding, represent their understanding in a variety of ways, both verbally and non-verbally, and therefore communicate both their thinking progressions and solution strategies. Number lines also help with the cognitive development of students in the classroom, allowing them to engage more consistently with problems intuitively. They can keep track with their progress on the number line whilst the teacher goes through the problem with them and monitor the steps they are taking. This results in a decrease in the amount of pressure on their working memory and short-term memory simultaneously, allowing them to process information more quickly.
There are 4 benefits for the use of teddy bear manipulatives in the classroom.
Firstly, they are an inclusive resource because they can be used by anyone in the class to learn or to teach the concept of skip counting. This includes all skill levels. They are also flexible in the sense that they can be used for a variety of topic areas within mathematics and across a variety of other curriculum areas. They also help support students' mathematical understanding, leading to deeper learning opportunities and abstract thinking. Thirdly, they support a wide variety of learning needs, which will be discussed further. They are a powerful tool for making classroom learning fun and engaging.
Number lines accommodate mathematical variability of concepts. An example of this is the continuity aspect, where this resource is able to reach an infinite number when organized effectively without making the line itself too bulky or overcrowded. Number lines can be effective as a visual representation in a variety of ways. For example, fractions can be represented by a number line as well, not just a pie diagram. This is important because it means that by using a resource like a number line that students are more familiar with, they can apply their understanding of its function to other mathematical topics like fractions. They are a tool for representational transfer. This means that if a common solution for a problem is absent, the transfer of representation of this problem to something like a number line can be used by the student to find an answer. For example, in a question such as, what is 6 less than 68, the student can transfer this question to a number line and discover the answer by skip counting down in increments of 2.
Teddy bear manipulatives have a number of strengths. For students, they are usually engaging due to the tactile appeal and also their visual appearance in terms of their bright colours and their shape. Students particularly enjoy when they can maneuver the resource freely and are likely to be more engaged in their learning. It is also a valuable resource because it provides that bridge for students to move from concrete understanding to abstract understanding and develop mental calculation skills. Piaget particularly supports this point in his theory of development, suggesting that there are stages which children must experience to reach this level of abstract understanding. Therefore, the students must first experience these ideas on a concrete level using manipulatives such as these teddy bear counters to be able to develop their understanding of further abstract concepts. Maneuvering small objects such as these teddy bear counters provides other opportunities for development in a child's fine motor skills, particularly in the younger years where this is an essential part of their development. Furthermore, maneuvering the teddy bears is a sensory activity and is therefore likely to be a more poignant experience for students and as a result improve their cognition and their ability to retain information and concepts taught through the use of the teddy bears. Theorists Piaget and Brunner highlight the need for students to experience deep learning and conceptual understanding through direct, concrete experience. Physical activities opposed to textbook learning will lead to greater memory retention. This is also due to the fact that the concept is made more relevant and real to students as they can physically see the objects in front of them and move them to represent their understanding. This is made more realistic to them than viewing numbers on a page. This resource offers further benefits to the learner, providing them with ownership of their learning and an avenue to organize and communicate their understanding. In turn, this will result in greater confidence and a more positive disposition towards mathematics. It will encourage them to begin to verbalize their mathematical understanding, which is essential in solidifying their understanding and developing solutions. Finally, the visual and physical nature of the teddy bears can help in the student developing multiple ways to solve problems in a form that works best for them and best supports their understanding.
In order to be responsive to all students' learning needs, changes in mathematics instruction can be as simple as this change in instructional tools. This visual representation is valuable as it supports the abstract concepts of skip counting in a student's mind and applies it to something they can see. By using a number line, students can see the maths actually happening in front of them. In skip counting, they can see the relationships between the change of the overall number and the equal spacing on the number line between jumps. Number lines can be helpful for many students' learning needs. For example, maths anxiety. Students having their own personal number lines, either on their desks or ones that they can change depending on the task, will have more time to work through problems by themselves at their own pace. Whether or not their answers are correct, for these students it is important that they are trying to engage with the resource and that they are learning how it can help them work through skip counting tasks. Therefore, a visual representation will help them feel more comfortable and less time constrained. English as a second language or dialect. Visual representations allow for the teacher to not only explain what they're learning, but also support it by showing them what is happening and what exactly they mean by skip counting. Disinterest or disengagement in the concept of skip counting. The teacher will be able to use this visual resource to help the students learn when they think that all they are doing is playing. Number lines can be taped on the floor, and the teacher can introduce a game like Bunny Hop, where the students attempt to catch a beanbag, and if they succeed, they skip count by 2s each time whilst hopping to reach a pile of 10 carrots at the end of the line. Difficulty forming imagery in the mind's eye. The physical representation of the change in numbers and the evenly spaced jumps in skip counting allows them to see what the teacher is telling them. Difficulty keeping track of numbers and processing disorders. Students are able to use number lines to keep track of where they are at when skip counting, either by drawing on the number line or putting their finger in place of where they are up to. This allows them to process their understanding of what is happening in their own time and continue when they are ready. Gifted Students Extension. Teachers can extend students' use of a number line and encourage more abstract thinking, for example, by removing one or more numbers on the number line and asking the student to determine what the missing number is. Dyscalculia. Number lines provide a visual representation of how the numbers can be manipulated when skip counting to change the total, how the numbers change in a calculation, and how the equal spacing in skip counting relates to basic, repetitive number facts. The presence of these numbers on a number line means that they are holding less in their working memory and less likely to feel overwhelmed by the amount of information they have to process.
The learning needs that were identified as potentially arising when teaching skip counting can all be met through this resource. Teachers have seen a decrease in math anxiety when introducing manipulatives in the classroom. This is due to their ability to enhance student motivation and self-efficacy. Students are likely to have more personal successes when using the manipulatives, which counteracts math anxiety and can lead to a more positive disposition towards mathematics. Students who speak English as a second language or dialect can also be supported. Using the bears to demonstrate the concepts can support the development of any vocabulary that they may be unfamiliar with. Students who have difficulty engaging or disinterest in mathematics may enjoy the tactile and visual appeal of the resource and enjoy learning through this. Other students who have difficulties forming mental representations of concepts or keeping numbers and information in their working memory will benefit from the visual aspect of the bears laid out in front of them. This will decrease memory load with less need to remember and hold numbers in their head. Students requiring extension will also be supported with this resource, as they can move to practice counting by 5s, 10s, or be asked to start from any number when counting, for example 6. This will be supported by the resource in this challenge. For students with dyscalculia, manipulatives have been identified as a strong avenue of support. Again, the multisensory aspect is useful. The children can physically see and move the manipulatives. Rather than think abstractly about the effect mathematical symbols have on the numbers, these students can actually see the numbers changing. For those students who may need assistance with counting principles before moving into skip counting, manipulatives are often concrete to developing these fundamental skills. Whilst having many benefits, the teddy bear manipulatives do have some limitations. Unlike the number line, the teddy bear manipulatives do not demonstrate continuity and linearity. This could be confusing for some students, especially in terms of place value. There is a concern that students may begin to rely on physical manipulation of concrete manipulatives, and therefore it is better that they are used with consideration and in addition to abstract strategies and mental computation. Manipulatives are not practical when manipulating larger numbers, whilst number lines are more practical in this aspect, as they can be easily altered to suit the desired range of numbers. Manipulatives tend to be instrumental in the younger years and help grasp fundamental concepts, but are not utilized as much as the number line in the later years and beyond. Teachers may also have to be aware of keeping students on task when using this resource, as it may be a distraction and considered more as play by students rather than used for math reasoning.
There are some limitations to number lines. Children have to count over the spaces between two numbers. For example, from 0 to 1 is 1. They may have the chance to miscount the numbers, and instead of starting with 0, they might count that line as the number 1. A number line, once drawn, cannot be changed for different values, as there might be more values to include than the actual number of spaces on the line. Therefore, in this sense, another number line has to be drawn. Number lines don't have the same aesthetic and tactile appeal. They can be manipulated in their own way, but the number itself cannot be held individually like teddies can.
The teddy bear manipulatives and the number line complement each other in providing a well-rounded visual experience that helps all students with different learning needs to learn how to skip count. Whilst they were both identified to have some limitations, these were often found to be fulfilled by the other resource when compared. Overall, their benefits demonstrate that they are an effective resource for teaching and learning and should be used in the classrooms in conjunction to one another.